Having done a lot of these Edexcel past papers now, we seem to get asked this a lot for 1 mark. Explain why this is an improper integral. I guess it's just trying to guide us, but as soon as you see an infinity up there, it's going to be improper. So improper, since upper limit is unbounded or infinite. Now we're asked to prove that the integral is a ln b, where a and b are rational numbers to be determined. Here we go. Actually, before we get into the integral, let's deal with this. This is partial fractions territory. We can't just integrate it directly. What we can do is express it as a over x plus b over 2x plus 5. Then multiply through x equals 0. That's going to give us 1 equals 5a. So a is 1/5. And then x equals minus 5 over 2. That will cancel out this left-hand term. And we'll get 1 equals minus 5 over 2b. So b will be minus 2/5. And therefore, we'll get, I'm just going to write it as 1/5 over x minus 2/5 over 2x plus 5. Of course, you could put the 5 as a denominator, but I'm going to be factorizing out the fifth in a second. So here we go. Here's our integral. Okay, so let me bring that fifth out. And then I will get 1 over x minus 2 over 2x plus 5. And at this point, we need to bring in the idea of limits. So I'm going to have 1/5 limit a approaches infinity of the integral from 1 to a. I'm only going to take the limit at the very end after I tidy things up. So we get ln modulus of x minus what's going to be ln modulus of 2x plus 5. You need to divide by anything because when you differentiate it back, you're times by 2. So it's actually in the perfect form. It's actually in the form f dash x over f of x if you want to see it like that. Now, at the moment, if you substitute a in and you let it approach infinity, this will approach infinity and this will approach infinity. So we don't want to do that. We first of all want to combine the logs together because they're going to sort of be cancelling each other out essentially. And actually, we could, you know what, we could just combine them together right now. So x over 2x plus 5. Then I'll get ln a over 2a plus 5 minus ln 1 over 2 plus 5, well, that's 7. Actually, that becomes plus ln 7. You're still holding off taking the limit. We could do at this point, to be fair. But that's going to become ln of 7a over 2a plus 5. Right, now to take the limit as a approaches infinity. Well, of course, the numerator is going to become infinite and the denominator is going to become infinite. But what that's going to mean, essentially, is that they're going to dominate and you can ignore the 5 and you're just going to get, for large A, this divided by this. And they're going to cancel each other out. So we're actually going to get a fifth ln 7 over 2. And that's going to be our answer. You know, that applies to lots of situations. So if we had 6x over, I don't know, 4x minus 3. As x approaches infinity, it's the same idea. This term is just going to become insignificant. X is really big, so these two are going to dominate. And then I can just cancel these out. Essentially, I can just say that, yeah, it's going to approach 6 over 4 or 3 over 2. Okay, that's just another example to compare with. So our integral we're asked for is a fifth ln 7 over 2, which is in the form asked for here. Well done.